Hello everyone, I hope you are doing extremely well. In this video, we are going to develop a generative AI application. This application helps the students in their exam preparation. Here we implement the RAG agent. The RAG is nothing but retrieval augmented generation. Like we'll give content or PDFs to the RAG agent or chatbot. Then chatbot use it to generate the answers based on the content which we provided. Let's see the demo of this project. A student can select any model from here, Deepseek, Llama, Llama 70p, Gemini, and Mistral, and can test any model. Here I'm using Llama 8b. And the first question I asked here, hello, I'm Srinu. Who are you? The model generated a nice response and as well introduced about this agent. And I asked provide me the important questions from entrepreneurship and new ventures. It given all the important questions from different categories: entrepreneurial education, planned publicity for entrepreneurial opportunities, and many more. And ask it again, what are the benefits and limitations of creating entrepreneurial forums? Answer this question clearly. So it explained in a clear way and effective way. Then asked, what is my name? It responded like, your name is Srinu. It means that the agent can remember all the chart history and generate the responses accordingly. Before deep diving into the practical implementation of this project, first of all, let's understand what is meant by a RAG agent. As we know, a LLM model can be like a user given a query to prompt, then the prompt is given to the LLM model. Then the LLM model can generate a response based on the pre-trained data. There are certain limitations are there. First one is that hallucination. Let's say a user given a query which is out of the pre-trained data, so that it is the LLM model can hallucinate and generate incorrect answers. To overcome these limitations, we use a RAG module, which means that a user query given to the RAG module. Then the RAG module can fetch the related content to the user query with the help of similarity search algorithms. And the user query and the related content is given to the prompt. Then the prompt is given to the LLM model. Here, the LLM model can generate a response based on the user query and the related content. Here, this process we call fine-tuned. This, with the help of RAG agent, we can fine-tune the LLM model to do certain tasks, either for organization or institution. Next, we'll see the steps to create a RAG module. First of all, we require some documents. It is impossible to LLM model to process the entire documents. For that, we divide the entire documents into small chunks. With the help of embedding algorithms, we convert the chunks to embedding vectors. The embedding vectors are the numerical representation of the text, and these embedding vectors can capture the semantic meaning between the words. All these embedding vectors are stored in vector store. It is also known as knowledge base. Next, we'll use the knowledge base in RAG agent. The RAG is abbreviated as Retrieval Augmented Generation. A user query given to RAG module. The RAG module fetches the related content from knowledge base with the help of similarity search. This part is called a retrieval. After retrieval, a user query and related content given to the prompt. Now the prompt is improved and enhanced. This part is called augmented, and the prompt is known as augmented prompt. After augmented, the augmented prompt is given to LLM model so that the LLM can generate a response. This part is called generation. The combination of three parts is called a RAG agent. Let's connect this RAG agent with the real scenario. Let's say in a classroom, a faculty is asking question to the students. The students can search the entire book and come to a conclusion and answer the question to your faculty. In the same way, a user query given to the retriever and the retriever retrieves the content and given to the LLM model. The LLM model can generate a response. This will happen in the RAG agent. Now, let's begin with practical implementation of this project. Open your favorite text editor and follow some simple steps to set up the project. First of all, create a virtual environment with the help of Kunda create command. Then activate the virtual environment with the help of Kunda activate folder path. Then after create a file requirements.txt and enter all the required libraries. Then after enter a command in command line pip install -r requirements.txt. With the help of this command, all the required libraries are installed in the virtual environment. Create another file .env and create Groq API key and paste here and create Hugging Face token and paste here. To create Groq API key, go to groq.com and click on free API key. Create your own API key here. And to create Hugging Face token, go to huggingface.co and click on access tokens, create a new token and copy paste there in VS Code. Create a app.py file and import all the required libraries, import OS, import time, import Streamlit as ST, which is used to build the web pages, and load.env is used to load the environment variables. Shortgrok is used to invoke the LLM models. The PyPDF loader is used to load the PDF content. Recursive character text splitter is used to split the text into small chunks. The Hugging Face embeddings is a Hugging Face model which is used to create the text into embedding vectors. The chroma is used to store the embedding vectors, and the create stuff documents chain is used to create a document chain with the help of LLM model and as well as the prompt. The chart prompt template is used to create a prompt template, and the messages placeholder is used to place the chart history in prompt. The create a retrieval chain is used to create a retrieval chain, also known as RAG chain. And chart message history is a base class to the chart history. Create history aware retriever is used to create a retriever to the chart history, which retrieves the chart history. Runnable with message history, it will invoke the LLM models with message history, and we imported all the constants like model mapping, dataset path, and ChromaDB path, which are defined in utils.py, like model mapping, the model name and its value, dataset path, that is env materials.pdf. In the dataset, I only provided with one PDF, that is entrepreneurship and new venture. It is a 90 pages PDF, and there is a lot of content is there in this PDF. I'm using that, and to store the embedding vectors, I use it ChromaDB to store them, and I'm importing the prompts, the system prompt and contextualized system prompt. Here, the system prompt, the prompt is used to define the behavior of the LLM. Here, I define a prompt which can define the LLM behavior. The prompt is "You are Quester, an intelligent and helpful AI assistant designed to support students in their exam preparation." Your primary responsibility is to answer student queries accurately and professionally, strictly based on the provided context. Here are provided key guidelines: context-driven responses, no speculation, conversational flow, encourage deeper learning, maintain a friendly and professional tone, so that the LLM model can behave the, with this prompt itself. And the contextualized system prompt is used when a user gives unclear question, then this prompt helps to refine and enhance the user query. The key guidelines are: use chart history, preserve original intent, no unnecessary alterations, maintain coherence. And I used these two prompts here and I imported in app.py. Call the load.ini function to load all the environment variables, specifically load Hugging Face token and Groq API key. And now define the page title for the browser, Quester A Study Assistant. We will see how this one looks in browser. For that, first of all, activate the virtual environment with the command kunda activate and give folder path. After activation, it will show that the activated folder path. Then run the app.py file. Streamlit run app.py. It will take couple of seconds to run. So after it successfully run, it will show the title Quester A Study Assistant. Now we'll write the code to define the sidebar. For that, simply write with sd.sidebar. In that, write the title Quester A Study Assistant and write the chatbot settings. Now we'll see how this one looks. This is how it looks. We can close it out and open it. Then write the drop-down box to select a model. For that, we are using model mapping.keys. So we'll define model name to store the value of the model key value. Finally, we'll see how this one looks in web browser. This is how it is looking. We can select any of the model and use it. Next, we will load the embedding model with the help of Hugging Face Embeddings. We use the model name, we use all mini LM L6 V2, and we load the LLM model with the help of chart Groq. Here we provide Groq API key and as well the model name. And next, we define a QA prompt with the help of chart prompt template, which is used to create a prompt template from messages. First of all, to the system, we'll give system prompt and we try to put chart history in the prompt and then we'll provide input to the prompt template. Next, we'll define contextualize the question prompt. We'll create the prompt template with the help of chart prompt template from messages. For the system, we'll give contextualized question system prompt, which we defined this one earlier. Then we'll put the chart history in the prompt and as well as we'll provide the input to the prompt template. Next, we'll try to create a function that is used to create or load the ChromaDB. Here we have two cases, either to load or create the ChromaDB. If the ChromaDB is not exist in the specified path, in that case we try to create the ChromaDB. Otherwise, we load the ChromaDB. For that, we have some simple steps to follow. First one is that we need to load entire PDFs from the provided dataset path. Then we need to create a text splitter with the help of recursive character text splitter, where each chunk size is 1000 characters and chunk overlap is 100 characters. Now, what we are doing is that we have in the docs, we have entire context which we are loaded from PDFs. Now we are dividing the entire documents into small chunk of documents where each document has 1,000 characters. Then, with the help of chroma dot from documents, we try to convert all chunk of documents into vector embeddings and we'll store these vector embeddings in ChromaDB with simple steps. So we'll give documents equal to final documents and embedding equal to embeddings. Next, we'll provide the ChromaDB path where the embedding vectors are stored. Then we'll return the vector DB. If the ChromaDB is already existed in the specified path, we simply try to load the ChromaDB and return. So return chroma persist directory ChromaDB path and embedding function equal to embedding. Now we'll call the defined function load or create ChromaDB vector DB equal to load or create ChromaDB and we use this vector DB as a retriever with help retriever equal to vector DB as retriever. Next, we will initialize the chart history. If the chart history is not there in session state, so we'll define session state dot chart history equal to chart message history, which is a base class for chart history, and we'll define messages if the messages is not there in session state, which is used to store the messages like session state dot messages equal to like it will have the role as assistant and will show the first one. First message that hello, I'm Krister, your intelligent study companion. How can I assist you in your exam preparation today? So this is the first message. It will be shown in the browser. And next one is that we will create a history aware retriever, which is used to create a history aware retriever with the help of LLM retriever and as well as contextualized question prompt, which we define the prompt in prompt.py. Then we'll create question answer chain with the help of create stuff document chain. We'll provide LLM model and as well as question answer prompt, which we define in prompts.py. Then we'll create a RAG chain with the help of create a retrieval chain. Here we will provide history aware retriever and as well as question answer chain. Then finally we create the RAG agent with the help of runnable with message history. First of all, we'll provide a RAG chain. Then we'll provide a callable function that is lambda session ID session state dot chart history. Here we'll provide in the chart history for particular session ID. Then we'll provide input messages key input and history messages key chart history and output messages key answer. Now we will write a for loop to display all the messages in the UI. For message in session state dot messages, we'll check out the avatar. If my message role is user, we go with human icon. If otherwise, we go with a robo icon. And we will display the avatar. Then we will write the message content. And if my message role is assistant, then the caption is there in message. We simply we'll write the caption, which is used to tell which model generated the response. Finally, it's time to take the user input. If user prompt, the st.chart input, ask me anything about your studies or exams. If the user enters a query that will be stored in user prompt, then we'll append this user prompt in messages like messages.append. We'll give role as user and content as user prompt. And then we will write this user prompt in UI st.chart message user and we'll give avatar then sd.markdown user prompt so that it will be written in the UI. Then we will use try block because we are using an API call. In that cases, if anything goes wrong, we need to handle that exception. For that, I'm using try block and start time equal to time dot process time and the response. Here we are using the RAG agent dot invoke Input, I'm giving user prompt and I'm configuring that to store the chart history in session ID. For that, I'm using configuration. Then elapsed time equal to time dot process time minus start, which will tells that how much time a model took time to generate a response for a user query. Then I'll store the response answer in bot response. Then I'll try to append this bot response in messages with a role is assistant and content is bot response and caption is the response generated by selected model and it took time to generate particular response. And I'll try to write this bot response in the UI with st.chart message assistant and st.markdown bot response and st.caption response generated by. Next one, if anything goes wrong in try block, it is captured by except block. So here I will display this error in the UI with st.error error generating response. Congratulations for understanding entire code. Now we'll see in the browser how it is actually looking. Congratulations for building your own RAG agent. Now we'll check out how it is actually looking and working. Here we can select any model. I'm going with Deepseek R1 and I'm asking the question, hello, I am Srinu. Who are you? First, it is given some reasoning part as it is Deepseek R1. It generated a response. Hello, Srinu. I'm Crystal, an AI assistant here to support you with your exam preparation. And it also given some questions to continue the conversation. What subject or topic are you currently focusing on? Do you have specific questions or areas you'd like to explore? Are there any particular study techniques you'd like to discuss? I'm giving that. Could you explain me what is entrepreneurship and new ventures? First of all, it is given some reasoning part. Then it given, certainly let's break down concepts of entrepreneurship and new ventures. It given entrepreneurship and it is defined very well and it given key characteristics of entrepreneurship. Everything is taken from the PDF which we provided and new ventures given some key aspects of new ventures and here it also suggested some questions for deeper learning and I'm asking who here the DeepSeek R1 is generating a nice response. Hello again, Srinu. You are a student preparing for exams and you have reached out to me, Twister, for support in your studies and given some questions to continue the conversation. This is all about the project. Thank you for watching this video. Have a nice day. Thank you.